Hello everyone, I am Decadent John Christopher Mueblas and I am going to teach you on how to get the CPA and the TCPA of targets by radar plotting. So, this is how a plotting radar sheet looks like. So when we see a target on the radar, we take the bearing and range of the target and note down the time of observation. So after that, you're going to plot that on your radar plotting sheet. So if we have here the time, the range, the bearing, we're going to plot it on our radar plotting sheet. For example, the first target we have seen is at 1800 hours with a range of 8 nautical miles with a bearing of 60 degrees bearing. So we're going to use our tools such as triangles and compass divider to locate this point, which is the 60-degree bearing. Using our compass divider, we are going to locate 8 nautical miles on this scale, 0 to 8, and we're going to locate as well the 60-degree bearing in this side, which means you will be able to locate this point, which we're going to label O. After some interval, take the second and the third set of observation of the target and plot in your radar sheet. So we have here the second observation at 1806, which is at 7 nautical miles with a bearing of 59 degrees, and another observation made at 1812 at 6 nautical miles with 057 degree bearing. Again, by using our tools, we were able to locate these two more observations, and after that we're going to connect these three observations so we can have a straight line. Right after we have connected these three, we're going to label the last point A. So this is the line of relative approach of the target towards our vessel, which we have assumed at the center of the sheet. Now for CPA, we need to find out the closest point of the line of approach to the center. To do that, we just draw a line perpendicular to the line of approach and measure the distance of this line from the scale in the radar plotting sheet. Will be it. So this is the center of the point to the closest line. So we're going to draw a perpendicular line here. Then the distance between that we're gonna measure with the range. Oops, sorry. Then that will be our CPA. In this case, our CPA is at 0.8 nautical miles. So to calculate 40 CPA, we just need to calculate the time required to reach at point C, considering it took 12 minutes to cover the distance of O and A. To do that, measure the distance C and A, that would be 5.8 nautical miles in this case. So from the distance here to here is 5.8 nautical miles. So this is the formula in getting the TCPA. We have here 2 nautical miles from the distance point O and A, 5.8 nautical miles point C to A. So TCPA, we have here 12 times 5.8 over 2 minutes. So in just simple calculation, we will be able to arrive with this 3.8 minutes, which will be rounding off to 35 minutes. So this is going to be our TCPA, 35 minutes. So the next thing we are going to do is to find the course and the speed of targets by radar plotting. So next, to find the course, the speed. To find that, from point O, draw your course into opposite direction and cut the distance of your ship has traveled for the time period of O and A. So in this case, we have 12 minutes. So let's say that your course is at 45 degrees and your speed is at 12 knots. So in 12 minutes time, your ship with speed of 12 knots will travel 2.4 nautical miles. So from point 0 or point O, draw a line in direction of 225 degrees measuring 2.4. So we will be reaching this point. We will be labeling that with W. The next The next thing we're going to do is we're going to join point W and point A to get the course and speed of the target vessel. We're gonna draw a line here. And then we measure the distance between point W and point A covered by the target 12 minutes. With simple mathematics, calculate the distance it would travel in 60 minutes to get the speed. So in this case, the course of the target is 300 degrees and the speed is 7 knots. Point WA measures 1.4 nautical miles.